We are going to design the state diagram for a simple vending machine. It's not going to dispense all these things here. It's just going to dispense one item worth 50 cents, and we are only allowed to deposit 10-cent coins and 20-cent coins. That means it has to handle the situation where we put in 60 cents and need 10 cents back as well as the product dispensed. So how can we formulate this as a finite state machine and write it up as a state diagram? We need to ask ourselves three things. What is the input? What is the output? And what do I need to remember? So for the input, we can either deposit a 10-cent coin or a 20-cent coin or do nothing, but we're ignoring this aspect. We're developing an informal finite state machine, which means it should be clear from the context when it transitions, so we don't have to handle the case of no input and stay in the current state. The output, well, we have to decide on two things. Do we refund 10 cents and do we dispense our product? And so we can use two bits. So the first bit, 0 or 1, for whether we dispense our object. So 1 means dispense our object, 0 means do nothing, and we have a second bit, 0 or 1, where 1 means dispense our 10-cent coin. So the output's going to be two bits. 0, 0 means dispense nothing, 0, 1 will mean dispense our 10-cent coin, 1, 0 will mean dispense the object, and 1, 1 will mean dispense both the object and the 10-cent coin. So we now understand our inputs, 10 cents or 20 cents, and we understand our outputs, a 2-bit number. As for the state, we can either work it out now, or we can start drawing the state diagram and try to figure it out as we go along. Let's take the latter approach. Here's my starting state as labelled. I haven't yet worked out what my state's going to be, so I haven't given it a label yet. But I do know that in my starting state, my output needs to be a 0, 0. I do not dispense the product, and I do not dispense a 10-cent coin. Now what I do is I consider all possible inputs. If someone deposits a 10-cent coin, where do I move to? And if someone deposits a 20-cent coin, where do I move to? I have the option of not moving, but if I don't move, that means that, firstly, the output cannot change, and that's okay because I don't want to dispense anything at this stage. But it also means that I can't remember what the input was. And because it's important that I remember whether someone deposited some money, I have to transition, I have to move to a new state. So let's consider what happens if someone deposits 10 cents first. So if 10 cents is put in, I need to go to a new state. I know that because I have to remember that money was put in. So I've got a new state here. I already know that the output is going to be 0, 0 because I do not dispense anything at this stage. But already I can start to figure out how I'm going to label my state. Maybe I'll leave it for a second though. We then go back and consider the other possible input. Remember, for each node, we have to have a transition for every possible input. So we finish one node first before moving on to the next one. So we go back to this node here and ask ourselves, what happens if 20 cents is deposited? So if 20 cents is deposited, by the same argument, I have to move to a new state. Why can't I move to the same state? Well, if I move to the same state, then when I'm in this state, I don't know whether 10 cents was deposited or 20 cents was deposited. So that's not good. I need to know the difference between 10 cents being deposited and 20 cents being deposited. Therefore, I need two separate states. So even though the output is the same, this state means only 10 cents has been deposited. This state means 20 cents has been deposited. And now we sort of know for sure how we should label our states. We've stumbled across the fact that our states need to represent how much money has been deposited. Note that we don't have to know the order in which the money was deposited. It doesn't matter whether first a 20-cent coin and then a 10-cent coin was deposited or the other way round. All we need to know is that in the starting state, 0 cents has been deposited. In this state here, 10 cents has been deposited. So we can give our states any name we like. A, B, C, D is fine. But if we can give them a meaningful name, so much the better. So let's label the states by how much money has been deposited, because in this example, that's exactly what they represent. Let's check. We have got a node labeled as being the starting node. It's got a state name, it's got an output, and it's got one transition for every possible input. We see though, we forgot to label this one. So tick, we've done this one. Now we move on to the next one and do the same thing. We say if we're in this state and a 10-cent coin is deposited, where do we move to? And if we're in this state and a 20-cent coin is deposited, where do we move to? Well, if a 10-cent coin is deposited, we don't have to know that I've received 2 10-cent coins. All I have to know is that in total, I've now received 20 cents. And so it suffices to have a transition like this. 10 cents moves to this node here, representing that if I've gone down this path here, I have now had 20 cents deposited into the machine. Every node has to have transitions for each possible input. So what if 20 cents was put into this one? Well, then we see from what we've been saying that I need to move to a new state labeled 30 cents to denote the fact that 30 cents has now been deposited. The output in this new state, still 0, 0. I do not dispense anything yet. And we go back. So we've done this node. We were doing this one. Check. I've got a transition for 10 cents, a transition for 20 cents. So this node's now done. I now move on to the next node. It can be either this one or this one, because this one and this one have both been done. If I go to the 20-cent node, I do the same thing. I just add transitions for each possible input. So if I have a 10 cent here, I go here. If I've got 20 cents deposited, then I'm going to move to this new state here. I will have 40 cents in total deposited. That's still not enough to buy anything, so I still have 0, 0 here. And I check. I've got my 2 transitions there. 30 cents. Well, if 10 cents is deposited, I move over here. If 20 cents is deposited, then I move to this 50-cent one, and something exciting happens for the first time. So 20 cent causes this transition. If I have 50 cents, then I need to release my object, dispense the object, but I do not dispense the 10-cent coin. Now I can't remember which way round we said we'd do this. What if we have it that the first number tells me whether or not I dispense my object, and the second number is whether or not I dispense the coin. So 1, 0 means dispense object, but not coin. Okay, where are we up to? So I've got 2 outputs here, 2 outputs here, 2 transitions here, 2 transitions here, 2 transitions here, 2 transitions here. I haven't done these 2 nodes yet, so I need to do these 2. So 40 cents, well, if I get 10 cents, I simply move to this one here, that's good. If I get 20 cents, I need a new state, 60 cents here. And in this case, I have to give the user both the product and a 10-cent coin. So I need to dispense both of them. We are still not done yet because we've got 2 nodes here which don't have transitions going out from them. Now something a little bit happens here. What would normally happen, you would expect, is that after you've dispensed the product, you then just return to this reset state up here. But we need something to cause this transition. So the way we've done it is we wait in the current state until someone deposits another coin. So we've dispensed a product, we're either here or here, and we're going to stay in this state until someone else puts in a coin, either 10 cents or 20 cents. So if I'm in this state here and I've dispensed a product, it's basically the same as being in this state up here, but it is fundamentally different because the output denotes that I've dispensed something. Anyway, I'm in this state here. What happens if someone gives me a 10-cent coin? Well, I transition up here. So that's for 10 cents. And what happens if they give me 20 cents? Well, of course, I just go over here. That's the 20-cent one. And for the 60-cent one, I've given back the 10 cents. And so I'm at zero again now. And so if someone gives me 10 cents, and I'll use a different color here because it's cutting across other things. If I get 10 cents, then I go to this state here. And if someone puts in 20 cents, then I move to this one up there. And that's it. We've developed a state diagram for a simple vending machine.